in this video, I'm going to show you how to use the law of cosines to solve any triangle. So unlike the Pythagorean theorem, which is only useful for right triangles, this particular rule it's possible to be applied to acute triangles, obtuse triangles, and right triangles. It is a form of, or an extension of the Pythagorean theorem. So if you recognize the Pythagorean theorem in it, that's great. But it has an additional piece to it, which involves the cosine ratio. So the first step, if you are wanting to apply the law of cosines to a triangle that you've been given, is to label all of the pieces that you've been given, all of the information that you have been given in your problem. Yeah, so I'm going to start by labeling the points. And I've chosen just the first 3 letters of the alphabet. I could have chosen other letters. Across from the capital A, the vertex called capital A, is going to be side A, so that's lowercase. Across from the capital B vertex is lowercase b, side, and across from C, lowercase c, like this. So the law of cosines looks at the relationship between these side lengths, just like the Pythagorean theorem does, but it also takes into consideration the angle measures, or one of the angle measures. So here's one form of the cosine rule. There are 2 other forms of it, and here I've got a squared isolated, or on the left-hand side by itself. I can rearrange the components and isolate for each of the other 2 sides, which is what I'm going to do in a moment here. But I'm going to start with this form and show you how that's useful for solving for an angle. And in this case, the a squared is what's on the left by itself, so I could find angle A using sides B and C. So I'm going to give you the side lengths to start with, and then we'll find the angle measure from there. So let's say that A is going to be 7, B is 8, and C is 9. I'm choosing integer values for these lengths, just to make it easier to put into the calculator when I get going on this. Okay, so given side length A, B, and C, I can use the cosine law to find angle A, angle B, and angle C. And I'll have to do those as 3 separate calculations. So to find angle A, I'm going to use a squared equals b squared plus c squared minus 2bc cosine A. And A was 7, so 7, 8, 9, B is 8, so that's 8, C is 9, and then cosine A. And I don't know what A is, so I'm going to have to use algebra and isolate for that value. So we got 49. Now this piece is where many students make an error, because they we try to do the addition, 64 and 81, and then a subtraction from there. However, this is joined, the 2 times 8 times 9 is joined to the cosine by a multiplication. So I cannot just combine it with these two, 64 and 81, with an addition or a subtraction. I'm going to have to deal with that multiplication piece before I can do that addition. So that's based on the order of operations. So what I can do is I can simplify the 2 times 8 times 9. So that's 144. So I've got minus 144 cosine A. So when you're looking at this statement as it is, you can simplify the 64 plus 81. That's 145. I haven't done anything with this 49 yet. So a common error for students to make is to try and subtract 145 minus 144. But the way that this behaves is not like that. Think of it like if you had a simpler problem to solve, like 5 equals 3x plus 4. Move this over a little bit. You wouldn't add 3x and 4 together to make 7 or something like that. That would be an incorrect algebraic step. You would have to initially deal with the 4, get rid of that 4 by subtracting it to the other side, and then you would divide by 3 to solve for the x. That's exactly the process that we're going to be doing here, because I have a constant value of 145, and then I have negative 144, which is a coefficient. It's a multiplier. So I'm going to have to do the similar process to what I would do in this example on the right. So I'm going to start with subtracting the 145 from the 49. And that's negative 96. Okay. So this would be in the example that I've given on the right. I've subtracted the 4, so now I've got something like 1 is 3x. I would divide by the 3 in order to isolate for x. Here I'm going to be dividing by that negative 144. And that's going to give me a decimal value, which is the cosine of A. That's 2/3, interesting. There we go. .6 repeating. So at this point, to find the angle measure, I need to undo this cosine. So the way that I'm going to do that is use arc cosine, which on my calculator, I'm going to use the second function button, and it's going to do cosine minus 1. So cosine minus 1 of that 0.6 repeating will give me angle measure A. So second function of the answer. And it tells me that angle A is 48 point, we'll say 2. So the process is very similar for finding the other two angles in my triangle. The difference is going to be which lengths I plug into my formula. So the second version of this law, which is solving for angle B, looks like this. I'm going to have B on its own. I will have A squared and C squared as the two squared values that are being added together, minus 2ab AC, so those same two sides, cosine angle B. I'm going to draw a little line here just to divide the work. Okay, so value of each of these. B is 8. 7 and 9. Cosine B. So start with simplifying what you can. So 2 times 7 times 9. 126. Add the 49 and the 81 together. That's 130. And as I mentioned before, a really common mistake for students to try and do is to do the subtraction because it looks very convenient. These numbers are very close to each other. But you can't do that because this is not actually 126, it's 126 times cosine B. So it's a coefficient. All right, so 64, subtract 130, negative 66 is negative 126 times cosine B. Now I divide by that coefficient. It's 0.523, etc. And I'm going to do arc cosine again of that value. So I've got that decimal value in my calculator. I am not going to clear it out. I'm going to leave it there. I'm going to go second function, arc cosine of the answer. That way my calculator puts in all of those values after the decimal point. There we go, the angle is 58.4. degrees. Okay, last tip, make sure that your calculator is in degree mode so that it will display numbers that make sense. We haven't seen radians yet, so make sure that you're using degree mode. Okay, my challenge to you is to use the third form of cosine law to find the value of angle C. Looks very similar. We've got the C squared now by itself. And it looks like that. So this is the one that I was saying is very clearly an extension of the Pythagorean theorem. If you take off that subtracted piece, that's the Pythagorean theorem. And this is the part that's taking into consideration the angle measure not being a right angle.